Topic is about AI-driven intelligent logistic tracking and coordinate system for multiple station operations. I am from Group 19, sir. My name is Manikanta. So our project is can be classified into four subtasks. First one is automate resource tracking. Second one is like enhance interstation communication, and third one is like providing the insights like dashboards. And fourth and last one is automate logistic and workflow automation. So, for the brief overview of our topic, our project, I have created a context free diagram where there are having like five entities like station. You can see a station, cloud services, IoT devices, users, and third party APIs. There will be one main process going on, that is AI powered tracking systems. Now, these stations will be providing their requests, and the AI powered tracking system will be providing the responses. Like station can provide the queries, and it can ask for the queries. It can receive alerts. It can also get the operation trends. Where your third party APIs can provide the external data like weather services and everything. And here the user can provide also have the same request as the station, but you cannot have the like access to the add the data. When it comes to the IoT devices, it will provide the real-time access to the data. And when it comes to the cloud services, it provides the both storage resources and the computing resources for the station. Now let's go into deep into the diagram, like level one diagram. Now from context level diagram, we have taken only one processor, right? Here AI powered tracking system. Now these will be divided into sub processes like interstation communication, predictive analysis, visualization, IoT data processing, and alert systems. The entities will be the same. The count of the entities will be same station, user, IoT, and cloud services. You can observe here there are three data sets: shipment database, historical data, and IoT. Here, shipment database is having the both historical data and current data. While come to the historical data, it is only having the predictive analysis of the data, like insights of the data, processed data. While you come to the IoT database, it will store the real-time data. So you can observe the data flow. When the station provides the queries to the interstation communication, it is receiving the responses where interstation communication will get the information for the shipment data and historical data. You can also observe for the similar to the other entities where like user is receiving alerts from the alert system, where alert is getting the data from the third party APIs and IoT. And also for the we can see the intercommunication between the processes, like interstation communication is providing the request for the predictive analysis to provide the predictive insights to the station. And also interstation communication also ask for the visualization for the station and as well as the user. Now so this is our whole project. Now we have selected only one portion of the project, that is automate resource tracking, where there are monitor the inventory levels, like what are the resources left over, and we can also add the resources to it. So it's like a database management system. We created a website so that everyone can access it. I mean, every station can access, and as well as the user can view the dashboard. So it also describe about the communication between the like what are the resources shared between the interstations, and we can also update the resources. And welcome to the what are the technical things we have used. I am mainly used a Flask, and for data set creation, I have uses SQL Alchemy and SQLite as the base. For front-end portion, I have used HTML and Flask templates. For data set creation, like I didn't get the available data for this project, so I created my own custom data using the different models for the each process. You can see the example of the different tables, like different relationships. So station table is having it's a unique ID name, location, and description. So station name is for station name, and location where it is located, description, and what does it provide, like a regional urban medical center. So this station is connected with the different tables. It is having one-to-many relationship with the other table, like inventory, demand history, distributions. And another table is product table. It describes about what are the products available and a description about it. And it is connected with the distributions, one-to-many relation between the distributions. When it goes to the third table, it is inventory table. Inventory table is for finding the relationship between the stations. Like in station, what are the products we are having, how much quantity we are having. And let's another thing is like demand history. Demand history is like what are the requests? So what are the requests we are providing to the inventory. So you can see here like station ID, what is the station and what is the product we are accessing, and when is the time, and what are the requested amount, and also distribution table, like a distribution between the different interstations. Like when we can take example of the Amazon, where the main hub will be providing different resources to the different regions, so that they can transfer the package to the user. Thank you.
Great presentation, Manikanta. You've perfectly captured the idea of the project. I must say the data flow diagram was looking really great. You've also broken down the different stations, what they are for, and how will each of them coordinate, what will be your data structure. This is what I exactly wanted from the first presentation, how to plan everything out and the diagram itself. So great work on that front. Second thing, like what's your partner's name? And like he didn't say anything.
Uh, his name is like Biswas Sahu, sir.
Okay.
I don't know, like I tried to contact him, but he didn't respond.
Okay, so you're doing this on your own?
Yes,
Okay, just a second.
Manikant, have you tried to contact them?
yes, sir. Actually, until yesterday, he was like, we have communication with us, but from yesterday, we didn't communicate. I tried to like call him, sir, but he didn't respond.
Okay, not
Okay, we'll try to intervene, but if you've done this on your own, then like another like better points for you. Like see, I think you've got everything sorted here, but like, do you have any working code for this?
Yes, sir. But
Okay, and
like,
have you included predictive analytics for this?
okay, sir. Like currently, I only done the addition, like creation of the data sets. If I wanted more, I
Okay.
can show it, sir.
Yeah, send it over, send over whatever you have. I think you've thought out most of it. I'll help you out on the predictive analytics part.
Okay,
Because
sir.
see, yeah, so see you've managed out all the SQL tables and it is how it's going to happen. But then the uh, like the niche of this project is that you predict the shortage before it happens of any product at any workstation that issues the commands automatically to the central hub, which like tells you the warehouse that where to ship what product
Okay,
before
sir.
it comes to a shortfall, basically.
Okay, sir.
Okay, so great presentation, everything's nice. Send me over your code, like whatever you have on your group, and like we'll work together on that later on.
Okay. Thank you, sir.
Yeah, we can move on to the next group, sir.
Okay, sure. And any comment from Ankit?
No, the presentation was perfect.
Okay.